Hello guys, it's Johnny time and welcome to another smart contract hacking tutorial. Today we're gonna solve the 9th challenge in Damn Vulnerable DeFi version 3, the newest version, and this challenge is called Puppet version 2. This is gonna be super interesting challenge and I can't wait to get started and solving it together with you. So without further ado, let's get started. So Puppet V2, Puppet version 2 is kind of like more advanced version of Puppet version 1, which was the previous exercise. If you missed it, check out my complete Damn Vulnerable DeFi solutions playlist. And this one, the developers of the previous pool seems to have learned the lesson and released a new version. Now they're using a Uniswap V2 exchange as a price oracle along with the recommended utility libraries that should be enough. You start with 20 ETH and 10,000 DVD tokens in balance, and the pool has 1 million DVD tokens in balance. You know what to do, right? So we have to steal all those juicy million DVD tokens, and these times it seems like the developers learned the lessons from the previous one where they used Uniswap V1. Now they're using Uniswap V2 exchange. So we can also open and go through the docs or the development docs, developer links of what is Uniswap V2, how the smart contracts look like, but we might get to there later. First, I want to overview the smart contract that we need to hack, the Puppet version 2 smart contract. So I'm heading over to the contracts folder and here we have Puppet version 2. So this is our smart contract that we need to hack. It's all Solidity version. Maybe we have arithmetic overflows here and maybe not, we will see. But we know that versions prior to 0.8, we don't have protections with arithmetic overflows. Here we import some contracts from Uniswap, the library and safe math, and define an interface for ERC20 tokens. And this is the contract. We use safe math. So maybe we don't have arithmetic overflow. That's why we use safe math. We define some parameters like the Uniswap pair, the Uniswap factory. It's probably going to be the pair of wrapped ETH and the DVT token that we're going to use this pair liquidity to get the price quote for the DVT token compared to wrapped ETH, the token and the wrapped ETH. We have a mapping for deposit. So which address deposited, how many, we don't know still if it's like wrapped ETH or DVD tokens. And this is the constructor. We just pass the contracts parameters and we set them, the tokens, we're wrapping them with interface of ERC20 tokens, and the pair and the factory, we just set the addresses. Now we have here 3 functions: borrow, calculate deposited of wrapped ETH required, and get oracle quote. So the borrow is the entry point. This is the external function that users can access in order to borrow certain amount of tokens. So they're going to pass the borrow amount, how many tokens they want to borrow. This is going to be DVT tokens. And here we're going to calculate how much wrapped ETH the user needs to deposit in order to borrow this amount that he requested here in the borrow amount. And we pass it to the calculate deposited of wrapped ETH required. This function, we'll get to that later. Then we transfer the user, we use the transfer from function to take the wrapped ETH from the message sender to this smart contract. This is the amount that we got out of the calculation. Now the user need to approve this Puppet contract to spend the wrapped ETH or the transaction will fail. Then we increase the balance in the deposit mapping of the user. So this is the deposited wrapped ETH. So we basically make sure that we know that he has this balance. And then we transfer those tokens to the user. So the DVD tokens that he requested to borrow, we transfer, and if it fails, we revert with transfer failed, and eventually we emit an event. Now it's time to understand how we determine how many wrapped ETH the user needs to deposit in order to borrow DVD tokens. And that's how we have this function, calculate deposit of wrapped ETH required. So we send here the DVT tokens amount that we want to borrow, and here we have deposit factor, which is 3. We get the oracle quote. So this is the price of DVT tokens, the quote of the oracle. We'll see what this function does later. Then we multiply it by the deposit factor, which is 3, and divide it by 1 ether. And as you know, 1 ether is 1 multiplied by 10 in the power of 18 because it's in 18 decimal numbers. So this is not only one, but one with 18 zeros. This is how you can look at this number. So now we need to understand how we actually get the quote, the price ratio between wrapped ETH to DVT, and this is this function over here. So it receives an amount and it gets the reserves from the Uniswap smart contract, right? So we use the library, we use the get reserve function of the factory and the two tokens, wrapped ETH and the token, and then we get the quote of the token. We can jump into these functions, get reserves, simply gonna sort the tokens and give you the reserves of the smart contract, right? So it's just gonna give you the reserves of the smart contract. It's two state variables that are stored in the Uniswap pair smart contracts, and as you can see, this Uniswap library is gonna get a pair for these two tokens, token A and token B, and then when it has the pair address, it's gonna wrap it with a pair interface and call the get reserves function and then sort it according to token A and token B. So using the pair contract, we can get the reserve, the state variables, and based on these reserves, we use the Uniswap quote function, right? This one, in order to get a quote for a certain token on the pair, basically the ratio between one token to another. So we use the quote function. Now, if you feel that this is a bit too complicated for you and you don't understand how Uniswap works and how DeFi protocols work, such as AMMs and lending protocols, this is why you should really consider taking on the smart contract hacking course, because in this course, we're going to cover so many fundamental concepts for smart contract security and hacking, including the most known and common DeFi protocols such as Uniswap and Aave and Compound and MakerDAO, and even vaults like BeFi Finance. So all these things will be covered in the course, and you will be able to grasp the fundamentals of how Uniswap works, factories, pairs, the library and all these contracts, how liquidity provisioning work, and then this one is going to be easy peasy for you to understand. Now, I don't have time to understand in depth here what it means Uniswap pair and Uniswap factory, but again, if you want a deep more dive, check out the smart contract hacking course. Now, already while observing this Puppet Pool smart contract, I want you to take a break and try to think what kind of issue do you see here on the way that it retrieves the prices of the ratio between wrapped ETH to DVT tokens. There is an issue here. It's not okay. You can do some kind of Oracle manipulation attack here. And I want you to pause the video, think before you continue. So before I will tell you the vulnerability that I see here that we can potentially exploit. Right, so in this one, they use Uniswap v2 get reserves function. So they don't use the token balance of the pair like they used in the previous Puppet exercise, but now they take the reserve state variable. Now it's slightly better than the previous version because in this way we cannot utilize flash swaps. And again, I don't want to get into flash swaps and how they work. This is something that we cover also more in the smart contract hacking course. But even though we cannot utilize flash swaps to manipulate the liquidity, we can still make a huge swap because relying on reserves of a single Uniswap pair as a price oracle is very not a good idea, especially if the liquidity is very, very low, because with small amount of money, we can come, make a swap, make a trade using this pair, using this liquidity pool, and then change completely the balance of the tokens, the ratio of the tokens. Now, if we change this ratio, we make this Puppet smart contract to think that the price is completely different than what it's supposed to be. So with significantly a relatively low amount of tokens, DVT tokens, we can just dump those DVT tokens to the liquidity pool. And after we dump them, this Puppet Pool smart contract will fetch the price from the liquidity of the DVT tokens, and it will be a small price. It will be very low price because we just dumped a lot of DVT tokens to this pool. And if you remember in the setup of the exercise, we have 10,000 DVT tokens, which we can just dump to the pool and decrease the DVT token price. And then we can utilize this borrow function and get those DVT tokens from the pool. Because we think that the price of DVT token is so low, we won't have to deposit that much wrapped ETH in order to take all the 1 million DVT tokens. So this is gonna be my attack plan. Now, guys, we cannot utilize flash swaps in Uniswap, but it's worth mentioning that even if we didn't have the capital to dump the DVT tokens on the Uniswap liquidity pair, we still can utilize flash loans in other protocols, right? So if we have another lending protocol that gives us flash loans of DVT tokens, we can utilize those flash loans in order to get big amount of DVT tokens, dump it for a slight moment to the liquidity pool, right? Then exploit this Puppet version 2 pool smart contract, then pay back the loan to the Aave protocol or Compound protocol. But all these kind of things are advanced things that we're gonna cover in the smart contract hacking course. So if you want to learn more about this and practice all those attack exploits and POCs and join an awesome Discord community, closed Discord community, get a certification and much more, consider checking the discount link in the description below for the complete smart contract hacking course. Exploit the Puppet version 2 pool. Now, I don't need to deploy a smart contract for this attack because I can just do all the actions from my EOA account in the JavaScript file, but I do like to deploy smart contracts because I want to do it in one clean atomic transaction. And therefore, we're going to go to the player contracts folder and create a new contract. I will call it attack Puppet version 2.sol. This will be our malicious contract. I will just copy all the code for the previous attack Puppet and gonna clean it up. So I will remove this one. I don't need the Uniswap V1 exchange. I do need an interface for the pool, but this time it will be borrow with borrow amount and external. It will be borrow amount. We don't need a receipt in this one. We just need an external and it's not going to be payable this time. In the previous Puppet, it was payable and now it's not. So this will be attack Puppet version 2. And let's just clean everything here. I want to clean everything. And let's start with the constructor. So what do we need to receive in the constructor, guys? We need to receive a few things, okay? Before we do the constructor, let's design our attack function. So function, attack, and it will be external. So first, we will want to make sure that, let's fix it to external. We want to make sure that only the malicious player EO account can trigger this attack. So we'll do require message.sender equals the player, and for that to happen I will need to store the player here in the constructor. So player equals message.sender. So the account who deploys this smart contract is going to be the player, and here we'll define address private immutable and it will be player. Perfect. So we added access control. Now what do we need to do in this attack? First of all, we need to swap 10k DVT tokens for wrapped ETH using Uniswap, right? We want to dump all our DVT tokens to the Uniswap. Now, after we got the ETH from the Uniswap swap, we want to convert this ETH to wrapped ETH because the Puppet version 2 pool expects to receive wrapped ETH and not native ETH. So I will do here convert ETH to wrapped ETH. We get ETH from the swap, we dump DVT tokens, we get native ETH, we will receive it using this receive function in our smart contract, and then we will convert it to wrapped ETH. Then we will need to calculate how much wrapped ETH we need to approve the Puppet pool, the vulnerable smart contract, to get in order to borrow all the DVT tokens. So I will do here calculate how many wrapped ETH we need to approve to borrow all DVT tokens. So once we know how many DVT tokens we need, how many wrapped ETH we need in order to borrow all the DVT tokens, then we're gonna approve the pool to spend our wrapped ETH and ask to borrow all DVT, right? Now, once we did that, we want to send, last part is send all DVT tokens and wrapped ETH to the player or the EOA account. Okay, because we need eventually the attacker EOA account to have this wrapped ETH and DVT in order to success this challenge and pass those tests. If we go to the test file, we can see over here that the balance of the lending pool should be 0 of the DVT tokens, and the balance of the player should be greater than the lending pool. So now that we have the attack plan, we can start think of what variables we need. First, we need to pool, so it will be I pool. It will be private, immutable, and it will be pool. So here we'll receive the pool address in the constructor address, and it will be pool, right? And it will be a pool equals I pool, and we will wrap the pool address. Awesome, so we have the pool. Another thing we need to know in our smart contract is the Uniswap exchange or router smart contract. So I'll do here address. I will call it router, because we need to swap tokens through the router. So let's add here I Uniswap router, and it will be private, immutable, and router. Now guys, in order to interact with the Uniswap smart contract, we need to implement the interface of the swap function. We want to swap the tokens, so we can go here to the docs. We have here V2 protocols, and we will need to go through these docs and see how we can swap tokens. So swap, maybe here, this is example of how to swap up. We need the dev, docs. So guys, I'm just gonna jump directly to the Uniswap repository V2 periphery, and then inside contracts we have the interfaces. So here we have iUniswap v2 router 02. So we can just do this, and we see that it inherits also from 01. So I'm just gonna copy all those interface functions to my malicious contract, the interfaces, so I can interact with the Uniswap router. Even though I don't need all these functions, I will still be happy to use them right here just to import them. So I have this Uniswap v1 router. Maybe we'll remove all these not necessary functions like add and remove liquidity. We don't need this. We just need the swap functions. So I've removed these ones. And we have here swap tokens for ETH, swap tokens for exec tokens. We don't need all these functions, to be honest. We just need swap exec tokens for tokens. So this would be enough. Swap exec tokens for tokens. Yeah, all these are not necessary. I can actually remove them. And also this is not necessary. And I definitely don't need this interface over here. So this should be enough actually. I just picked the functions that I'm gonna need from this. I also don't need to access the factories. So I will just do this iUniswap v2 router. And here we're gonna set the router. So we will do router equals iUniswap router, and it will be the router address. We will also need to know what are the token address. So we'll do address, and it will be token. This will be the DVT tokens, right? So we will do here another IRC20 private immutable, and it will be the token, and also IRC20 private immutable, and it will be wrapped ETH. We also want to know what is the wrapped ETH address, okay? So the token is gonna be token equals IRC20 with the token address. And regarding wrapped ETH, we don't need to send it in the constructor because we can simply just receive it from the Uniswap router. We have this getter function, wrapped ETH. So we'll do, let's make it lowercase, just out of convention, and wrapped ETH will be equals let's do just router.wrapped ETH. So we are receiving here the wrapped ETH directly from the Uniswap function, and we need to wrap it with IRC20. That's it. Now guys, we want to use the swap exec tokens for tokens in order to swap the DVT tokens to wrapped ETH. The amount that we want to swap, it will be a constant. Let's do something like constant uint 256, and let's call it constant uint private constant, and we will call it dump DVT amount. This will be the amount that we want to dump, and it will be 10,000 tokens, right? 10,000 tokens. So it should be 10,000 Ether. So we're going to dump 10,000 DVD tokens. And now we need to use this function to do that. Okay, so we'll do it here. So we'll do something like router.swap tokens for tokens. And now we need to fill all the parameters. Now, guys, we need to fill all the swap parameters. So the amount in is how many DVT tokens we want to dump to the pool. And we already set the constant dump DVT amount. So we can just paste it here, 10,000 tokens. We will have to send those DVT tokens to this malicious contract in advance from the JavaScript code. Amount out mean is how much minimum tokens we're willing to receive as of the swap. Now we know that the liquidity is gonna have how much? We don't know actually. We need to check the test file in order to see how much liquidity. Uniswap initial wrapped ETH and Uniswap initial token reserve. So we have only 10 ETH in the liquidity. So we will expect to receive at least 9 Ether from this swap because we know that we can never get all the liquidity. So we will expect to get just 9 Ether at least minimum. The path, we'll need to set the path. The two will be address this. We want to receive the tokens to this smart contract, and the deadline will be block.timestamp. Now, I know it's not safe to do block.timestamp, but just ignore it for this sake of the exercise. We're just going to do this. It's going to work because it's the same timestamp, but it's not safe to do this kind of swaps in general because of front running and other things that I explain more in the course. And I'm just gonna do block timestamp this time. Now the path, we need to set the path. So the path should be an array of the tokens that we want to swap in the right order. So I'm gonna define here a new address array, and it will be here memory. It will be in the memory, it will be the path, and it will be new address of 2 items. 2 items are gonna be at this path, at this array. The first item is gonna be the address of the token. This is the token that we want to swap from, right? And path at number 1 is gonna be equals the address of the wrapped ETH token because we want to swap the token, the DVD token, to wrapped ETH. Okay, and now that we have the path, we can just pass it to the swap function. Now, hopefully, after this swap, we dump all the DVD tokens to the pool and we receive some ETH. I want to add some payable because we might need more ETH in order to do this exploit. Maybe 9 Ether or 9 point something Ether won't be enough to drain the Puppet V2 pool. And the next thing I'm going to do is convert the ETH to wrapped ETH. Now, the IRC interface does not come with the deposit and withdraw function that exists in wrapped ETH. That's why we'll have to define another interface. Let's call it iWrappedETH, and it will be inheriting from IRC20. And we're just going to add one function, the deposit function, deposit, and it doesn't get anything. It's external and payable. You can look at a wrapped ETH contract and see that this is the function to deposit wrapped ETH. And deposit ETH and get wrapped ETH. We send ETH to this function and we receive wrapped ETH. And this is what I'm going to do here. So we'll do, and here I need to change it, sorry, from IRC20 to iWrappedETH. And also here. And now I can do this. I can do wrapped ETH dot deposit, and here I will send simply the value. So the value is going to be, what is the value? We want basically to convert all our wrapped ETH to ETH because we need to utilize it with the borrow function. So the value will be all the balance of ETH that this smart contract have. We want to convert all the ETH that we have in the smart contract to wrapped ETH so we can utilize this wrapped ETH in order to exploit the pool. And we have some typos, so I'm just going to change it here to wrapped ETH. Yeah, I made an error. When you want to call a contract and send the ETH, you should put these brackets outside of these normal brackets. So this should be supposed to be working. So we prepare the path, we make the swap, then we deposit all our ETH and convert it to wrapped ETH. And now it's time to calculate how many wrapped ETH we need to improve in order to borrow all the DVD tokens. And I'm going to utilize the same functions here. So we just need to get the reserves and then calculate the deposit of wrapped ETH required. So since this is public view function, I can just call the Puppet pool contract and get the amount. So I will just implement the interface and call it directly from my malicious contract. So we'll add it here, and it will be just, instead of public, external. And we can just call this function to get the required wrapped ETH to borrow all the tokens, okay? So here we will do something like pool.calculate. I don't need everything, just the function name. And now we need to send the amount of DVD tokens that we want to borrow. Now, what is this amount? We want all the DVD tokens, right? All the DVD tokens is 1 million DVT tokens. So I'll make here another constant on the top of this contract, and I will call it borrow DVT amount. And instead of being 10,000, it will be 1, 2, 3, 1, 2, 3. So we have 1 million DVT tokens that we want to borrow. And this is the parameter that we're going to pass to the function. And it will be uint256 required wrapped ETH. Now, at this point, we can add some logging so we can know exactly how much ETH we need extra to send to the contract in order to borrow all the DVT tokens. So I'll add here console.log, and I will do something like a contract wrapped ETH balance. This will be the current balance that we actually have right now in the contract, and required wrapped ETH. How much wrapped ETH we need actually to borrow? This will be the required wrapped ETH. And the balance of the wrapped ETH, we can just get a balance. So we'll do wrapped ETH. Let's make another variable, uint256. You know what? Let's just do it here. Wrapped ETH dot balance of, and it will be address this. Now, before we actually continue the attack, I want to deploy the contract and see how much we're able to dump the price of DVT and how much wrapped ETH we are getting, so I can deploy and initiate the attack with the right amount of ETH. So what I'm going to do is go back to the JavaScript file, and I'm going to deploy here my malicious contract. So I'll do const, let's do attacker contract factory, attacker contract factory. And it will be await ethers.get contract factory, and our factory will be attack puppet v2 from the player account. This is the account that's going to deploy it, and this dot attacker contract will be attacker contract factory dot deploy. We're going to deploy it with all the parameters. So first the pool, then the router, and then the token. So the pool, let's find the pool. Where is it? Landing pool. This will be our landing pool. Then we have the exchange and the token. Sorry, the router. So landing pool, router, and then token. These are the contracts that we need to send. So it will be landing pool dot address, then the Uniswap exchange.address, then the token.address. Not exchange, sorry, it should be Uniswap router, not exchange. We want the router smart contract to swap the tokens. Now, we want to transfer all the DVT tokens from our EOA account to the malicious contract that we just deployed. So await token.connect. We will connect the player account, and we will call the transfer function. We will transfer to the attacker contract, and we're going to transfer all the DVT tokens, which is the player initial token balance, all the 10K DVT tokens. And now that we transfer the token, we can just call the attack. So this dot attacker contract dot attack. This time, I'm not going to send any ETH, and I want to see how much wrapped ETH I need more in order to complete the attack. So let's just run it like that and see what happens. Guys, we forgot two things. We forgot to add here an await before deploying the contract, and we forgot to approve the Uniswap router to swap the DVT tokens. So I'm going to just do it now. Token.approve. The spender is going to be the address of the router, and the amount is going to be the dump DVT amount. And now this should be good. So let's try to run the tests. So yarn puppet v2, and let's see what we got. Cool. So we have here the contract wrapped ETH balance, and we have the required ETH balance. So this is the balance that is required in order to borrow all the 1 million DVD tokens. And we can just open a calculator over here and do something like this number minus this number. It will be a very big number. So it's 1.95 ETH, right? So, sorry, we need 19.59 ETH because it's in E19. So we move the dot one and then move the dot one here. So it will be 19.6 ETH almost. So we need to send to the contract extra 20, almost 20 ETH. We have, lucky us, we have 20 ETH. We just need to send 19.6 and should be enough. And we can just complete the attack. So let's just go back here. And now the value that I'm gonna send here, it will be value. And the value should be our balance minus how much? Minus 0.4 or minus 0.2 ETH should be enough. So it will be player initial ETH balance minus, let's do minus 0.2 ETH, okay? So we will leave 0.2 ETH for transaction fees. So it will be 2N multiplied by 10N multiplied by 17N. So it's simply 0.2 ETH. Our balance minus 0.2 ETH for transaction fees should be enough because it's between 19.8. We can actually do, let's leave for us 0.4 ETH because we don't need to send all the ETH. We just calculated the right amount, so we don't need to send more than that. And now it's time just to drain the pool. So first we want to approve the pool to spend our wrapped ETH and ask to borrow all DVT tokens. So approve. Let's approve the pool. So it will be wrapped ETH.approve. We're gonna approve the address of the pool. And the amount, we're going to approve all the wrapped ETH that we have in the smart contract. So it will be wrapped ETH.balance of, it will be address of this smart contract. So we are approving the pool to spend all the wrapped ETH. And then we want to ask to borrow all the wrapped ETH. So we'll do pool.borrow. And we just need to specify the amount of DVD tokens we want to borrow. So the borrow DVT amount is 1 million tokens. So I will just copy here the borrow DVT amount parameter. So let's do it like this. We're going to borrow all the DVT tokens and then we're going to send the DVT tokens that we just stole from the pool and the wrapped ETH to the player. So we'll do token.transfer. We will do just the player account and this will be token.balance of address this. So it will be the balance of this smart contract and I have one extra and here it will be wrapped ETH dot transfer to the player and it will be wrapped ETH dot balance of address this. And this should be enough, guys. This is supposed to be a beautiful exploit that will run in one transaction, one malicious transaction to deploy the contract, another transaction to transfer the tokens to the contract, and another one to trigger the attack. And all the attack happens here, right? We have an overview. We're gonna approve the router and swap the DVT tokens, dump them to the liquidity. Then we're gonna convert the ETH that we received to wrapped ETH. We're gonna calculate how much required wrapped ETH we need to deposit in order to borrow all the DVT tokens. We're gonna approve the wrapped ETH and ask to borrow all the DVT tokens that the pool have, and eventually send all the tokens from the smart contract to the player account. And now it's the money time. Now it's time to run the test. So we'll do yarn Puppet version 2 and cross our fingers. And we failed. And we have an error in our JavaScript file, maximum big int size exceeded. So let's go back to the JavaScript file. And I think it's because I did an error. It should be just multiplied and not in the power of. We have only power of 17. Let's try again. And it worked, guys. It's beautiful. We were able to exploit the Puppet version 2 pool smart contract and steal all the DVT tokens. We lost a lot of wrapped ETH, but it doesn't matter because the objective was to get all the pool initial token balance. Now, this was super exciting experience. I hope you enjoyed this video and you learned something new. And if you like it, please make sure to subscribe to the channel, turn on the bell notification button and smash the like button so more people can enjoy this awesome tutorial. Thank you so much and I will see you in the next one. Bye bye.